When I was in middle school, I never thought I'd become an engineer. Like many first-generation Mexican Americans, I worked in the fields at a young age. My parents believed in teaching hard work and responsibility, but they also believed an education was the key to a better life. With determination and support from my family and teachers, I found my passion for science.
My name is Elizabeth Vela Stephens, and I am a material science engineer at Pacific Northwest National Laboratory. I've always been fascinated by the materials that make out the world around us and how their different behaviors make them useful. I never thought that I would be performing research that would have a global impact. I work with a team of individuals to make vehicles lighter so they can be more fuel efficient.
Today's toughest challenges require teams of creative problem solvers who use science, technology, engineering, and mathematics to find solutions.
Consider this: 1 square foot sheet of steel. It's strong, which is why we use it to make vehicles today. But it's also heavy, much heavier, say, than this aluminum sheet of equal size. Automakers want to transition to making vehicles out of lightweight materials, such as this. Why?
Because a lighter vehicle requires less energy to operate, thus reducing both fuel consumption and greenhouse gases. Imagine if we could cut a vehicle's weight in half, that would boost its fuel efficiency by approximately 35%. That's no small gain. For example, such a boost in fuel efficiency would allow 10 cars to drive using the same amount of gas as 7 less efficient ones. Apply that to a national scale, and that could save 4 million barrels of oil per day. That's enough to fill 255 Olympic-sized swimming pools every single day. And it would eliminate 6 billion metric tons of carbon dioxide emissions, which is equivalent to the emissions produced by all American households over 6 years.
But you can't create more efficient vehicles simply by swapping one material for another. We need new technologies to join, shape, process, and model them. P&L has a diverse team working to solve these challenges. Let's meet some of them.
I work primarily with metals for all sorts of different applications, making cars lighter, stronger materials. I worked in failure analysis of many different components. The bigger picture is to develop cars in this application that are safer because they have materials that can absorb more energy during a crash, and they're lighter.
Teachers made a big difference when I was growing up, learning different things, and I was really interested in a variety of subjects and that type of thing. Not necessarily even particularly strong in any of them, but always was really good with working with my hands and making things work. And so that applies really very well for developing technologies. Our work impacts the world, reduces the energy consumption, reduces greenhouse gases. It even impacts how much oil we need to drill for. I would advise anybody that's going through school to take what you can do and be willing to take that to the next level. We need you.
So when I come to work every day, I'm trying to advance our understanding of why materials behave the way that they do, so that we can design materials to behave the way we want them to. We want them to be stronger, we want them to be lighter, we want to be able to form them into the shapes we need them for in our automotive or aircraft or any application area. My advice would be to be curious, be willing to collaborate with other scientists or researchers or other people in other fields, and be willing to learn new things.
As teams like ours improve vehicle technology, we are literally transforming the world to become more energy efficient and sustainable.
But our work is never finished. The future will bring new challenges to be solved by the next generation of STEM professionals. Students like you. It will take passion and hard work, but you're not alone. You're surrounded by parents, educators, and scientists who are eager to support and inspire you to go the distance.